Welcome to LORIS, a web-based neuroimaging data management platform. This video presents a basic introduction to LORIS covering the behavioral components, followed by the imaging side including visualization and quality control, and finally delving into data querying and data dissemination. For details on LORIS functionality, how to obtain LORIS, and the many LORIS features not covered in this video, please visit our website www.loris.ca. First, a little bit of background about LORIS. LORIS is a modular system that integrates all aspects of a multi-site study, from data acquisition and storage to processing and dissemination. Through a standard web browser, users can perform a wide variety of tasks such as data entry, 3D image visualization, and data querying. LORIS also offers a secure, streamlined platform that seamlessly stores and links large neuroimaging, clinical, and genetic data sets. Please visit our demonstration database at https://demo.loris.ca. Please note that LORIS is designed to work best with a platform-independent browser such as Chrome. Once inside the database, you'll first see the home screen that can be customized with the information for your particular study. First, we'll cover the behavioral side of the LORIS database, where clinical, psychometric, and behavioral measures are stored. Then we'll focus on other aspects of the database. From the menu bar along the top of the screen, under the Candidate menu, you can either register a new candidate profile for your study, or you can click on Access Profile to view the list of existing candidates and behavioral or clinical data already entered for your study. This will bring you to a screen where you'll see all of the study subjects that have been registered in LORIS to date. This view shows metadata about each subject that can be filtered as well as sorted by any column such as site or subproject or by subject ID. Clicking on any candidate ID will take you to a list of all of that candidate's data collection time points in your longitudinal study. At top, you will see buttons to create a new time point and view or edit metadata about this candidate. Clicking on one of the time point labels will display the battery of behavioral and clinical instruments for that subject at that time point. Demographic information and other metadata is displayed at the top of the page and tracks the flow of subject data through the study stages from screening to visit to approval. There are some flags in the left-hand column that are used to indicate time point status and quality control steps applied to this time point. As an example, let's take a look at the ACE Subject Medical History form. Although this form has been marked as complete in the left sidebar, we'll click on In Progress to demonstrate how data entry works. Personnel performing data entry select or enter responses for each question on the form. Not answered is always an option to indicate for statistical purposes that data is not available for any given item. Once all questions have been answered, at the bottom of the form, click on Save Data, and data should be saved including any calculated scoring or calculated fields such as age. If there are any data entry errors, meaning data was missed or entered inappropriately, the form will not save in the database. Instead, an error message will be printed at the top, and within the form, error messages will be highlighted beside the field that requires correction. Once data entry is done, administration and validity flags can be set in the left sidebar, and the form can be marked as complete. Longer instruments may split data entry up over several pages. One important tool on the behavioral database side is our behavioral feedback module. To view it, click on the pencil icon in the menu bar and it will appear as a pop-up so that feedback can be viewed in parallel with any page in the database. Here users can view and enter feedback comments or flag errors of various types, such as scoring errors in a specific instrument or larger data quality issues that might apply across a candidate's time point data set. LORIS also provides the ability to perform double data entry, which is the practice of entering each instrument dataset twice in duplicate forms. Double data entry is highly effective for reducing the risk of errors in manual data entry. Once data entry is complete for a given instrument, the next step in LORIS is to review and resolve any discrepancies generated during data entry on that instrument, using a special tool called the Conflict Resolver. Located under the Clinical menu, the Conflict Resolver module displays all double data entry conflicts and can be filtered by instrument or by site. This module enables users to resolve any data entry conflicts directly, just with a few clicks, by selecting the correct answer for each data item. That explains double data entry in the Conflict Resolver module, just a few of the features LORIS uses for quality control on the behavioral side. Next, we'll show how clinical and behavioral instrument forms are added into LORIS. Instruments are added into the database in one of two ways. The first method is via the Instrument Builder module. This module provides a user-friendly way for users to create and code their own test forms with no technical knowledge. For each question in your form, select a field type and enter the question details, adding each response to the form as you go. Field types include text boxes, text areas for larger comment fields, drop-down select boxes, multi-select boxes, dates, and numeric fields. Once all fields have been entered, under the Save Instrument section of the Instrument Builder, enter an instrument name, and finally save the form, which will download a copy to your local computer. From there, the instrument can be added to the LORIS backend through a few quick steps detailed in the LORIS Developer's Guide. Scoring and other calculations can be added via script written in many common scripting languages. Since LORIS is open source, a developer also has the ability to edit the PHP codebase in order to manually create or edit instruments directly. Many other modules are available on the behavioral side of the LORIS database, and we encourage you to visit the demonstration database as well as our website www.loris.ca for more information. This brings us to the imaging side of the database. LORIS was originally built as a neuroimaging database for MRI data acquisition, and has been developed and extended over time to handle numerous imaging modalities and formats, including 3-dimensional and 4-dimensional datasets. The imaging browser has three important functions: storing and organizing imaging data, visualization, and quality control.